Well, for the last few years, we have grown quite a bit. So right now, of course, this is going to be a little bit more intense. If you, for all the participants, if you don't remember the stuff, don't worry. Everything you see here is going to be on YouTube again. And as usual, at the bottom of each of the YouTube video, we have the entire lecture notes in Google Doc. So drop down the important stuff. If you don't remember the number, the specification, the process, you can go back to the video and study on your own pace. And yes, I do recommend a very big thing. As you go forward, just like before, I mean, you guys are new. For the old dealers, they usually, what they do is that on Saturday, they would take a few of my video, do their own presentation or training class in their own shop. If you do that, I will transfer extra 10% for your discount when you teach. That means after you teach, if the customer decide to buy, I will transfer extra 10% on the discount through you. So it's actually more than 10% because you know you pay at the dealer pricing. Of course, this is dealer class. It's not enthusiast class. I know a lot of ordinary guys read it, but I want to stress to all my current and future dealers again, because some of them forget. When you teach class, you're in your office teaching this class or different sectors, because in most of my dealer like Vital Limit or even like X-Wing Custom, they will find a section and they will teach. They will do a donut or whatever on a Saturday to explain to their customer what this section of stuff will do. And they do 15-minute classes instead of like me, 6 hours. So that your customer will be able to learn from this through you. And then when they will run through this and they decide to buy, you send a PO based on that class. On your next order, whatever you order on it, I will take extra 10% off. So you transfer the 10% to him. Remember, your 10% is based on retail. So I will give you that, so it's more than 10% on your price. All right? So that's out of the way, so let's go into it. Well, first of all, you will talk about our philosophy. The Firenock as a company, originally, we started as a lighter knock. But then, as more things go into it, the more we understand it, we find out that the knock shows a lot as I progresses. We move from a light down all the way to we are about this close to have our own bow and crossbow. So technically at this moment, besides bow and crossbow and the peep sight and the sight, we make everything. We used to be the one who make iBow sights, you know, the iPhone-based bow sight, except that was out in 2012 to 2014 until Apple changed the shape of the iPhone, because now there are 3 lenses on it. You can't do a bow sight with multiple lenses. You can't pick the lens to shape. All right, so now we are science of archery. The major difference is that all our products are actually based on science. In other words, it is not based on if. I think it sort of worked. We actually have science theory, and not to mention, at this moment, our company owns 43 separate archery related utility patents. And today, this is going to bring into multiple sectors. That on today's total classes, of course, the first one is Firenock, Aero Vein, Aero Systems, Aero Concept, Aero, and Bow Accessories. So those are my 6 main sectors. And people say, well, Firenock is just like a knot. How come we're going to talk about it for an hour? Well, if you really know into Firenocks, you will notice that it is not a simple system. Well, let me give you a little bit history of Firenock. Firenock originally is a military product. It is used by the US and British Joint Force Marine for instant runway project, which means that it is the project that was supposed to let the US and British Joint Force Marine to sit on a Harrier using a GPS and shoot out of 18-gauge shotgun shell to make lighted dots on the floor so it become a landing strip. That means a lighted knock have to handle 18-gauge shotgun shell or 33,000 pounds per square inch and hit the concrete floor, stay lit, and lit for up to, at that moment, no less than a week. And then we have blinking circuit. The blinking circuit is really critical because it's a number 1, number 3, and number 5. Because when you look at lander strip, you need to know which way to start. The starting end have blinking lights on it. And the blinking light is a lot brighter because it is the most important light for landing. That's the reason our current Firenock blinking is visible up to 2 miles in total darkness. All right, that's the basic background and history. All right, as a Firenock at this moment, we have 17 different styles of Nocks, up to 9 colors of Nock per style, up to 4 different functions. Each of the style of the LED have up to 6 colors, and we have up to 4 different batteries. Think about it. You have 17 shapes. Each of the shape have up to 9 different colors of Nock. So it's 17 times 9. Then you have circuits. As a matter of fact, right now we have up to 7 styles. Of course, the main style, which you guys may have familiar with, have 3 different functions. And then, of course, the matchway is the 4th one. It's your basic hunting, target, blinking, and up to 4 different batteries. And each of them have up to 6 different colors. People say, why do I need that many? Talk to a guy that have astigmatism with the color blindness. Red and red is no good. You may have to use something like a green on blue, or yellow on blue, or clear on yellow for some guys to actually see the Nock, because the guy can't see the colors. Oh, while we're talking about lighter Nocks, you can see that as of 2012, this, which is extreme short end cap, is mandatory now. Before that, we have the dual coil system that you can use without this. But then we find out that as of 2012, every single ball is actually going to shoot over 300 feet per second. The impact force exceeded 160 pounds. That's what my original 0.5 millimeter titanium wire can handle. And then not to mention sculpted with the Orion Extreme. This piece, with the Orion Extreme shooting into the spiderweb target, exceeded 270 pounds of force on impact. Because people are no longer using block, they are using spiderweb. It is not the speed that killed it, it's the impact of stopping that killed it. So now this is standard on everything we sell. Okay, let's talk about Nocks. Most people don't understand why a Firenock Nock is so much more expensive than others. This is the reason. There's only 2 companies on planet that I know of. When they make molded Nock, it's a single cavity, single mold. What does that mean? That means each of the mold. See, this is a very typical mold. You see that? That's an injection point. The flow will flow here and then flow up here and form this. This is your typical molding process. That's called injection molding process. Guess what the Firenock mold look like? None of this. We end up with one mold, one piece. Do you know why we go for that far? Because it guarantees every single Nock is exactly the same. Because when you do injection molding, do you guarantee the flow of the plastic to each piece, assuming they're all the same shape to start with? Do you know they are really the same shape? That's manufacturing micro difference. That's micro difference in flow, which means that's a micro difference in formation of the surface texture and the curing process of each cavity. Now, if you deal with a vertical bowl, that cavity process will cause the prong of a Nock to behave differently. This is one of the most expensive and critical part for most people who understand plastics. The single cavity is the only way to guarantee the consistency of a Nock. Now think about it. If you go and rent a machine to mold your Nock, you're not going to buy the machine, right? You're going to find a process to help you to make the. In our cases, we own the mold. Then we send the mold to people who are able to mold this. If you go to the machine and ka-chunk, each of the cycle of the machine, you have how many pieces? 8. In our cases, 1. Now after you made it, assuming this is the end of it, what happened to all these pieces? In most cases, people will grab it out, grind it up, throw it back in the hopper. It's called regrind. Guess what we do? We throw all of the above. Do you know why? Because the moment you regrind it, do you guarantee the flow of this material coming into this mold to be the same? You couldn't. In case of a single cavity on a G-Nock, the material-wise in here is happened to be 400% more than the Nock. So just that alone, that means on a typical, like I remember knocked out, they have 24 cavities per mold. We have 1. So on labor-wise, on production, we are 24 times higher. On material-wise, I'm 400% higher because I don't have regrinds. But I would absolutely guarantee the holding of the Nock to the string to be identical. That's very excessive. But how many Nocks do you really need when you hunt? It's the one that you're going to shoot, the most important thing. Most people do not use over 12 Nocks a year on the arrow cycle, especially in crossbow. In vertical bow competition, you figure that a really good person should use about 6 Nocks per cycle. Okay, that talk about this, why a Nock on the, what is a good Nock on the process. Let's consider this. You see that in the old days, all the Nocks are black, white, yellow, blue, if you remember old enough. You know why they make it like that? Because in order to make it not transparent, your molecular structure of the Nock and polycarbonate is a very even process molecule. That means that Nock is extremely durable. The moment you go to translucent, look at that. The structure of your tetrahedral is not actually, no, actually your hex or your tex is not structured. The reason it's not structured is that reason, since it's uneven, light can pass through. That's the reason, of course, being a lighter Nock company, this is critical for us, because those who are not able to work on the lighter Nocks, this is what's needed. What are the downside of this molecular configuration? This is very rigid, very stable. This is not. But that's what a lighter Nock needs. So what does that mean? When you use a lighter Nock, especially we do make metal lighter Nocks that you only see from the back, but on a translucent polycarbonate lighter Nock, this is critical. If you ever shoot through a deer or the arrow touches the ground, you change the Nock. Why? Because if you got scratches on the Nock, what does that mean? That means the surface structure of a Nock is being destroyed. People say, what's the big deal? I scratch plastic all the time. Yes, I understand that. But at low temperature, especially under 4 degrees, this translucent plastic is going to behave closer and closer to glass. So if you scratch it and score it, what does that mean? When you apply pressure, when you shoot it, the chance of it can crack right here. I mean, on crossbow, it's not that bad. On vertical bow, especially your XS size, your G size, is extremely, extremely critical. Because you're dealing with a structure that have a possibility of scoring and cracking in low temperature. People say, I shot summer all day long, no problem. It's true, because you haven't reached the point that this molecular structure and the outside structure is going to behave like glass. When they behave like glass, just like when you score glass and you apply pressure, you're in trouble. Or that's what your intention is. But these should not really do this. And the second time, when we make the Nock, translucent polycarbonate or this grade of polycarbonate, the curing process is from the outside in. As a matter of fact, you notice a lot of Nock is sort of soft. You can make it flex. Why? Because only the outer shell is hardened. That's the difference. The Nock, all polycarbonate Nock, based on a true molding process, is cured from the outside in. In other words, the surface of the Nock is an exoskeleton. So when people say, oh, I will just cut the Nock, shape it, make it larger with a file, what do you just did? You just like when you look at a beetle, you decide to scrape some of the hard part off the beetle, you just take the shell off. The guts are going to be everywhere. That's exactly the same with this. The lower the temperature, the more you get into the same situation. So a lot of people don't understand. In today's high-speed, high-power boat world, a lot of plastic is not designed to handle this. Give you case in point. The Firenock S-Nock is so engineered. A Carbon Express knot is about 10 to 11. A gold tip is 12. A boning is 12. This is 7.6. Think percentage-wise. It's close to 45% lighter. And this can handle a 120-pound push. And a lot of companies will tell you, when you push over 80 pounds, the Nock will break. But then, this is so structured on the outside. If there's any blemish or disturb of this outside, your Nock's gone. So what can guarantee you? You absolutely have to make sure the Nock is in pristine condition. If you shoot through an animal, what does that mean? You have a possibility of scoring the Nock. If the arrow touched the ground, that means the Nock can touch the ground, which means you can score it. When you can score it, you can scratch it, it can crack, it can break, you can have dry fire. That's what it means. So, which also explains why when you buy a pack of Firenocks, a standard pack, you always got double the Nock. In case of a 6-pack, like our hunting target combo pack, we actually give you 18 Nocks per pack. All right. Now, there's another thing that about our Firenock system that we got our first ever patent on. You notice that on the Firenock S-Nock, A-Nock, E-Nock, G-Nock is very different from other companies. Like the Firenock S-Nock, like when you buy a boning, say a boning Nock or a Carbon Express Nock, like Carbon Express will fit a perfectly 244. You buy a gold tip Nock, you'll fit a perfectly 246. You buy a carbon tech, you'll fit a perfect 244. You buy something from, say, a carbon impact flash shaft, you fit a perfect 242. And a carbon force is 243. So now, as a Nock company, remember we at Firenock, we started as a Nock company. So which one do we fit? Do we fit carbon impact at 242 or we fit gold tip at 246? Which one should we fit? Answer is all of the above. But then, how do you fit 5,000 variants with one single Nock? This is one of our patents. You see that? Normal, every single Nock you see on the outside has 6 ridges. They are evenly distributed at 60 degrees. What does that mean? When you push in the Nock, you get 1,000 or less, and all 6 ribs will push against the Nock perfectly. Which also explains why in the olden days, when Eastern have the excess Nock, the moment the temperature dropped, the whole Nock will fall out. No, sorry, not Eastern, the one made by Luminac, they will fall out because the plastic shrinked. So how do you overcome this? In the case of excess, which is really a whole lot more difficult, because like the excess is a 204 size. Do you know what's the difference variation in the market on a 204 is? Carbon Express is a 201, 202, not a 204. And on a Carbon Impact, it's closer to a 201. A Black Eagle is a 205. A Gold Tip is a 204. An Element can be as much as 207. So which one do you fit? Now you've got 8,000 variants. So how do you overcome all this? This is what we come up with. It's called an uneven space oblong compression system. You notice that there's only 4 grooves on it? Not 8, not 6. And not to mention, you see the rib is much higher comparatively. So the whole idea is that when you push this into Nock, it forces the perfect round circle into this form. You press this and this thing will compress or elongate. Now you're teaching this whole another circle to behave like an elongated egg with the outside compression. Now you can pick up that 2, 3, 5 thousandths, which is the same thing with our G-Nock. People say, oh, G-Nock is 166. No, it's not 166. Eastern is 1665. Black gold is 165. Firenock is 166. So again, remember the smaller diameter, that last number become very big. The variation become dramatic. That's the reason you say, oh, I just got this knot, I want to fit from this arrow to that arrow. Have you ever tried to pull a Common Express arrow and try to put it in the gold tip? It will fall out right away. And at the same time, try to put a gold tip into a Common Express shaft. You're going to split that because now you're 2 thousandths out. That is one of the most important things. How do we make a good knock? Okay, this is the first thing. You need the knock fit. But then, of course, we don't live in a perfect world, and we have all kinds of troubles. So what happened when in the first time when I designed crossbow? You notice that we have 2 O-rings, which you guys are familiar with, since I know you sell tons of crossbow. Do you know why I come with 2 O-rings? Because in the crossbow world, if you use an Eastern crossbow shaft, the ID is not 300, it's 298. And then if you happen to have some older gentleman who insists on 2219, that's a 303. On a 2216, that's a 306. Now you're looking at 8 thousandths variance. And at that moment, I want to make 1 knock. Well, guess what? That's what I did it, with 2 O-rings. Now in the case of even more difficult situation, we make a knock, and we got company like, say, Gold Tip on the Crossfire, which is become called the Gold Tip Laser 2 Kinetics, also called other brands and Gold Tip Laser 2 Extreme, whatever that is. You know the biggest deal about that shaft is? That's the only shaft on this planet is 270 thousandths. All other like your Carbon Express, like like Eastern Full Metal Jacket, they are 283 to 285. So, how many people often bought Gold Tip Kinetics? Gold Tip Kinetics Laser 2. Not many. But for the guy who need it, what can they do? They can get a Weiner, which is to fit 285. I designed it, if you shave off the ridges, the tubing will fit at 270. That's how you're able to handle that. For example, in case of, say, you still have gentlemen in the older days who like the ACCs. ACC use unit bushings and G-knocks. And ACC size are crazy. If you say ACC, say 329, that you can use an A-knock, a little bit modification, got it. But what happened to the 339 or the ACC 335, 370, 360? The ID is 250 thousandths, which is 4,000 bigger than an S-knock. How do you fit it? This is where the tricks come in. You will see that on our notes on all our modification on those arrows, we actually show you detailed modifications. On the ACC 370, 360, 340, sorry, 370, 340, you actually have to put super glue inside the shaft. What do you do that for? You use super glue to build up 2 thousandths on the inside, so your 246 will fit. Yes, there's a lot of really weird things out there. And then in the case of the on the 229, which is happened to be a 290 spine. No, actually that will be a that's a 290 spine. That specific one demand you to shave the ridges slightly because you use the E-knock. E-knock is 235. You need to shave it down to a 227. Or even up to a 217. And this actually fit ACC 349, which is the 235. Yes, that's a lot of work. But for your customer who have been shooting his ACC for the last 25 years, who bought 16 dozen that will never, ever, ever change, that's how you help him. As a matter of fact, that is not that is only one arrow I do not recommend people doing too much. It's the Black Eagle Spartan, because it happened to be the only one that's 230. 230 is the middle of everything, and that was where the tough part is. All right, this is the part that most people never truly understand, and I'm going to share that with you. See, this is what a lot of companies design their Nocks. The black arrows are the force that's applied by the Nock to the string. Think about it for a second. The Nock lifts the string, touches the very end before you go. If the Nock is not perfectly molded, when the Nock touches the top end on the right, on the Nock all the way to the right, what will happen to that arrow? If that two on the final two arrows, one side is more higher than the other or harder than the other, your arrow is not going to string, isn't it? Now most people tell you, this is so minor. This is so minor, if you don't pass 60 yards, you can forget about it. But now we're talking under high-speed camera. This is what I found out. Now in the case of the second Nock, you notice that notch is even more pronounced. That means if there's any slight action, that Nock will absolutely give you all kind of problems. That means from Nock to Nock to Nock, you get a bag of Nock from them. What cavity do these Nock come from? You have no idea. How hard or how flexible is each Nock? You have no idea. But you expect them all to shoot the same. Do you think it's possible? Really? If you put on a shooting machine, you'll find out that it is not remotely possible. Now in case of the people say, well, because in the old days, people say I put the Nock on the string, and the Nock fall right off. So people put ribs. See that? There's ridges. See, 1, 2, 3, 4, 5, 6 ridges on the Nock. What does that mean to the string when it comes out? It bounces 6 times inside the Nock before it comes out. Isn't that ridiculous? But that's what everybody's using. Look at what this is the first pattern of the Firenock system. You notice that this two line is not paralleled. It's 1.7 degree offset on each. So when the string pushes the Nock to pass the shear lock process, what happened to this two prong? It opens. So how many times does the prong touches the Nock? Answer is 0 after it leaves the shear point. That's the same design we design in every single crossbow Nocks. So since our Nocks are so precise, single cavity, single mode, virgin flow, we now can design this thing to be 100% identical every time you shoot it. Then people say, oh, wait a minute. What happens if you flip the Nock from top to bottom, bottom to top? Then it's not the same, right? Absolutely, you are absolutely correct. That's the reason when you take a closer look at every single Firenock Nock that's indexed. That means when you put your Nock on the string, there's a left side on the vertical bolt. There's a left side of the Nock and the right side of the Nock. You want to make sure all Nocks go on the right same size so they will shoot the same. Because when you mold it, guess where the injection point of the Nock is? The tip of the opposite side of the index. That means the flow of the plastic is coming on this part. Flow the whole Nock. And that's your output point. That means the plastic reaction of every single Nock, this two prong, is not the same. So imagine if you make a mold, you do not take this into consideration. Even if the mold is made perfect, just the flow of plastic on the reaction of the plastic would have impact how the arrow will shoot and behave here. Now let me ask you this question. How many of your customers would care about this? Technically none. But you as a dealer who is going to have more knowledge than him or her, you think this is important? If you want to shoot that 120 yard at 30 miles per hour wind and you want to hit the same spot within 1 inch, this is part of the thing you have to care. Yes, you hear me right. I got double archery customer shooting deer with a vertical bow at 115 to 120 yards and drop every one of them when they aim. That's how good you can build arrow when you learn how to build arrow. Because in today's technology, the arrow will do the job. Now is the customer good enough to hold the bow, the form, to shoot it? You will give him the equipment to make it happen. That means you, just like a guy with a super sniper come to you and say, I want a 1700-yard gun. You say, no problem, I'll build you one. Instead of handing him an off-the-shelf one, good luck. No, you're going to make it happen for him. Of course, he do have to pay you, and that's what you're here for, right? Okay, now let's do a fast summary. What makes a Nock critical or good? First of all, single cavity, single mode. That's the first part. Manufacturers has to be good. Second, we need to have the design to make it fit the shaft. Now this is not true in the case of a G-Nock. Do you know why it's not case in the G-Nock? Because most people's shaft is not concentric on the G-Nock. Yes, you hear me right. It's not concentric. You grab a G arrow, 166. A lot of the manufacturer, because this shaft, except mine, they use centerless grind. That means when you look at the wall thickness, they are not the same. So what happens when you use the insert or a Nock in it? They're off-centered. That's the reason G-Nock is the only shaft you have to physically tune and spine index. And yes, you're going to have arrows that don't behave well. Because the wall thickness is not the same, the Nock is not in the center. It's not because of the Nock, because of the shaft. Finally, the shear lock system. So you can see that this two-part is one of my first patent back in 2006. And I was not very good at patent law at that time. That is 13 independent claim and 32 dependent claim. I should have split the Firenock patent into 7 patents, but I didn't know better. So you can see the Firenock patent is very critical. Now, I say a lot about Nock, but just like Nock is only hippling onto a string, am I right? So how good is the string? Now, I don't want you to think, so I'll sit back a little bit and think. You need to think the Nock as your tires, your string as your rim. You build perfect tires, but you have a crooked, unround rim. What do you got? How good you with the car drive? Horrible. Do you know that every single string that ever made up to today is forcing your Nock to turn left? That means if you build a good string and put a good Nock with a good fit, your arrow will absolutely guarantee to turn left. Even your cock vein, the vein with all the aerodynamics and everything, is to turn right. Isn't that funny? Yes, from history of time to today, that is not a single string made, except somebody went through extreme. Every single arrow, when you shoot it, is going to turn left. The tighter the Nock fit, the more it will turn left. Why? It's because, if you think about it, your Nock have height. The moment when you're leaving this, it's like a knuckleball. Your string on it is grabbing the Nock. Every single string ever made on this planet is based on a right-hand turn original string-based system. When you do a right-hand turn, on the serving, on the twist, when you're trying to do the serving, overhand right to left, which is how you make sure the string do not unwind or creep. That itself, the whole process, guarantee the Nock to turn left. That means when you shoot the arrow, you see, oh, my arrow turned left. So the arrow naturally spin left. No, it's all because of the serving and the Nock. How do we overcome this? We'll talk about that later. But let me show you why I make this. This is called the arrow bow serving jig. It's the only serving jig on this planet. They have a full 9-element drag system in it. There's five carbon drag system with 4 titanium components. Now, if you look at BCY, look at Biter, you're lucky to get that thing to set up more than 3 pounds of pressure. No, I'm not joking, 3. This thing is set up to 32 pounds consistently. You can do up to 8,000, up to 12,000 RPM. It will maintain the drag. I mean, I remember when Tim out of American Best Bowstring were testing, they tell me that, Dodge, after 6 hours, that whole thing is hot. I say, of course it's going to be hot. You're serving at least 15-pound pressure for 8 hours non-stop on a really busy day. You got to do two jobs. It's going to be hot. You need to chill that. Because this will get hot if you non-stop doing it. So how do you overcome it? The beauty of this system is that, see that drag shaft? That is the only serving jig on this planet that lets you keep the pressure. So you can buy multiple of this and say, hey, the first one is Angel Majesty 12,000 at 12 pounds. The second one is Angel Majesty, say 10,000 at 15 pounds. So you can mark exactly what you have, and you can get a different one of this and put it on this and use it. This is a serious production jig system. Why is this so important? Because when you make this good to fit your Nock, very critical, every single Firenock made is to fit 110 to 112 thousandths OD. That means the outside of this Nock should be 12,000 exact. That means the Nock is going to hold this with about 1,000 space, and it will clip out the best. That's one of the most important number if you're a string builder and you use Firenock. Because see, the current world we know of, the serving can be 98,000 to 137,000. That's a 25 to 30% difference on the OD. Can you imagine you put a rim that's 30% bigger than what your tire required? That's how ridiculous the world is getting. Now, you see this we specifically make this thing oblong. See that? It comes to this point and sticks out. You know this phenomenon happened the most in what bow? You guys should be very familiar with it. Raven. You notice when you put a Raven orange Nock onto the string, what happened to that string? It absolutely deforms. So what happened to that? You squeeze some of the serving on this point. So when you relax that Nock, because remember, Raven is the only Nock on a one of the Nocks on a crossbow that behave like a vertical bow. So that's the reason this absolutely applies. So when you push it at that moment, the Nock is going to drag, the Nock is going to drag on this string on both sides. That means every single shot you shoot, the release is not the same. You hear me right? The release is no longer the same because every time the Nock click on it, it deforms the string. So until the string is deformed to a certain extent, the shot is never consistent. Because you're grabbing and dragging. How consistent can you get? Answer is none. You have no consistency on how the Nock going to behave. So if you got a good because if you look at a lot of strings, especially some aftermarket strings, that is not very well made. Don't get me wrong. Some of my friends with the string industry, they got perfectly round strings. When it's perfectly round, does this bulge or compression will be if they're made right? Answer is it will not. That means how good is that Nock to string? Because if the string is made right, with the right OD, the weight of the Nock is insignificant. That means you got your consistent shot because you got your consistent serving OD. With your consistent ID of the Nock, they match. That means if you like cars, would you buy uneven size tires, uneven size rims? You will not. So why would you do this? Now, this ABSSJ, which is arrow bow serving jig, is one of the more important part. But then, we got a lot of customers in the string building industry and say, hey Dodge, that stuff is great, but I'm a small guy. I don't need that kind of production environment. Give me something simpler. So after the ABSAJ came out in 2017, so after 6 years, I listened to what everybody said. I'm going to make the ABSSA dual drags, D square. What it does is that now instead of using a memorable drag system like the previous one, this one is totally based on dual carbon plate friction. That means you can on the fly adjust, but the difference is that this one actually using a 4-spring compression system. That means when you tighten the knob, you're not just tightening the quote-unquote into the thread. It behaves like a spinning wheel drag. If you fish enough, you notice inside your drag knob there's one spring, right? But that one spring can be uneven on left and right. Only on super high-end spinning reel have more than one spring, like your sea bass, which have 6. We have 4. So now when you turn the knob, you can do micro adjust pressure on these 2 drag surfaces. That means you, instead when you're using on the fly, you say, well, the pressure's a little bit off. Let me add half an ounce more. You can actually turn about a quarter turn and add that half ounce pressure to this. Because the drag surface, see how big this drag surface? This is actually 35 by 15 drag surface. That means the OD of this drag surface is 35, the ID is 15. And the old one, there's 2 surfaces on this. While that one have 9 drag element. And there's 5 drag plates. That's only 15, I think it's 12 by 5. So the total drag surface, this is actually double of that, even if they have 10 surfaces. But the good thing is that this one is on the fly manual. That one is memorable. That's the reason that one retail for $250 without the spool. This one retail for $200 with the spool. And that one you can buy multiple elements and change. This one is per piece. That means if you do multiple sizes, colors, pressure, you have to buy multiple of this. A lot of people like that. But that one, you see that one have a slot in it. The slot, a lot of people don't like it because if they don't hold the jig absolutely perfectly, when you serve the jig and you touch the edges, you'll fray and break the line. In these cases, because most of them use manual, this piece in the hole, instead of a slot, this is actually a hole now. That hole is based on a titanium nitrate. It is a gold nitrate ring that you use in fishing rods. We put one right here. So what's the chance of scratching it? 0. Now we're putting a titanium nitrate fishing guide right here. So this is called the ABSSD tube. This will come out in September 2023. So this is a new one. This is version 1.0. All right, that's the string, serving, and so on. Let's talk about specific knocks. This is majority of Firenock vertical bull knocks. The S knock, 202 to 242 to 246. Your basic gold tip Carbon Express. Carbon Express is 244, gold tip is 246. As I said, if you put the inside, you use super glue gel, not super glue gel. You coat the inside of your shaft, this will fit the ACC 360 because it's 250,000. Okay? If you shave all the ridges, become 240. So now you can fit the carbon impact, which is a 241. Of course, 243, like the carbon force from the original carbon force from PSC. PSC now use gold tip shaft, so it's 246. So this S knock is pretty much our most common, is the first knock that comes out. The A knock, yes, the number is 202 to 204, but you know it's more like 201 to 207. Yes, when you hit 207, this knock will fall off. So when you cut an element, make sure you're on the right side and you cut it right. Otherwise, the knot will fall off because some of the shaft inside is 207. And I make this to fit 205, 206. 207 is a little bit too far-fetched. The E knot is 232 to 235. You know, so wait a minute, the number is very small because it is originally to fit ACC 349, which is also your ACC Pro Hunter. In today's world, we also have the Michael Waddell, the Hex, and the Ion. They are all 235. That's the reason the E knot exists. In the case of the G-Nock, it's 165 to 1665. Yes, that's the Eastern injection, 1665. Yes, that's for a tiny G-Nock. And finally, we make the V-Nock. Because if you look at it, if you are into, say, a gold tip 22, that's a 300 ID shaft, right? Do you know why in the old days there's always a thing called the unit bushing? Because Eastern find out they make too many sizes on aluminum shafts. The ID change a lot. And molding of a Nock is extremely expensive, but machining a bushing is not. So what's wrong with the bushing? Like Raven used the bushing. Every time you put a bushing, is the Nock touching the shaft? You just added another variable to the perfection of that engagement. That's the reason we make the V-Nock, to fit, quote unquote, the gold tip 22. Unfortunately, not everybody follow the size. Like if you decide to shoot Carbon Express, Hippo, that's a 302 size. So now, will this fit well? No, it do not fit well, because it fit a 300. That's a 302. Why wouldn't I make a compression system to fit that? It was made before I understand that, because I make this just like I make for the crossbows. It will fit an absolute 300 perfectly. Why do I so critical on the crossbow 300 size? Because in the case of a crossbow, there's so much power. The variation get dangerous. Because when you compress it, you also stress it. That's the reason on the 300 size and above, we do not make any variation. It's none. Okay? All right, let's talk about the Firenock Nock size on the crossbow side. This is fun. You notice that? This is what we did. Look at that. You notice that every single one step is 10,000 variants. That's by design. Because see, when we first designed Firenock Nock, the first one we ever made was the D-Nock. The original D-Nock is 165,000 with a 298,000 OD, perfect fit. Because it was meant to fit the PSC Tech 15. Because the Tech 15 ID is 298,000. It's not 300. And the Tech 15 serving is 163. So we fit 165 on it. So that we're 1,000 around. This is plus and minus 5 always. So the basic rundown, if you want to know the numbers, are the C-Nock is for the original Bowtech. All Bowtechs 125,000. Or when you got a Raven with the Nock really compressed down to the string, you don't clip right, that's a C-Nock. The next one is the U-Nock. U-Nock is 135,000. Now, this is one of the most important things when you do a Nock size to serving. If you got a crossbow, if you got a rail on it, what's the number one rule? The Nock cannot hold the string tight. That means just like you shoot a 10-point. You want to use a full containment system. You need to clip the Nock on it, and you're able to move the Nock sideways to the string. That means the Nock must be loose on the string if there's a rail. Wait a minute. Didn't Raven Nock have the clip tight on the string? Yes, absolutely. But the difference is that the Raven have no rail. Then you ask yourself, why is it so critical? The fact is that when you shoot a crossbow with a rail, do you absolutely guarantee both cams, both limbs, on the entire power stroke, there is no variation? You cannot. So what happens if your Nock is tight on a string, on a rail crossbow? Because of the micro variation, your Nock on the track will go up and down the rail as you go down. What do you think your accuracy will be? Which is also, I remember last 2 years ago, Lauren from Brookholder RG called me, Dodge, the J-Nock don't work on any of the 10-point bow, and you cannot get a group at 30 yards under 4 inches. I say, It's not possible. It should be. Because 10-point changed the serving size from 155 to 165,000. So using the J-Nock on the new 165,000, when you shoot the bow, the Nock go up and down the rail. Your accuracy suffer to extreme until we put an M-Nock, which is a moon Nock. Well, guess what? You no longer grab the string, but you also lost the safety of a full containment system. So I told him, go back, put the D3 Nock, and everything worked. Accuracy comes in, safety comes in, everything comes in. So what does that experience teach me, or teach us? When you shoot a crossbow, if it's a rail crossbow, the Nock will clip on the string, but it has to be loose. Then why do we do that on Raven or Tech 15? See, PSC was very smart. You notice PSC on the Tech 15, how do they guarantee the Nock don't move left and right? They use a string loop on it, didn't they? So how did the Nock move left and right? It can't. It's always on the center of the string. Now remember, the string is going to move left and right a little bit. But it is a non-rail crossbow. So what is the most important part? The arrow rest. What does Raven got? An arrow rest. So, but since Raven do not have a string loop, how do you guarantee the Nock stay with the string on the entire process? The string must be tight to the Nock. Just like you shoot a vertical bow, you put your Nock onto the string. If your string loop is tall, you put your Nock on the top of the loop and bottom of the loop. What does that mean to your shooting? It's pretty horrible, you know that. It will be very horrible. Now, those are our crossbows. You can see the string serving size. Let me run down on the 5 specs. This is for Bowtech or the worn out Raven. This is for a brand new Raven, or it is for the Scorpio Death Stalker. This is for the Scorpio Normal or the Parker. That's 145,000. This is for the older Mission. I make this originally for Mission because Mission used to be 155,000. 53,000, so I put 155 on it. And this is also for the older 10-point, which is 153,000. Then all three, 165,000. The reason for that, because this too is for Tech 15. When they use their original arrow, that's 290,000. This is 300,000. And then, of course, when we found out that 10-point and other bow company decided that they absolutely use 165,000. So we make a short prong. By the way, the short prong design are all under our patents. So you see why people don't use that at all. Because that is what we own the patent, and if they decide to use it, they have to pay us. All right. Those are what you call it now. Just so you know, a lot of people call it capture. The word capture, that word actually belongs to Parker. The Parker Nock is not a capture Nock. It's an extended, elongated, or over-exaggerated moon Nock. Our Nock actually have a patent design in it. It actually grab the string and hold it. The correct Nock word is clip-on Nock. Again, if you shoot a rail crossbow, the clip-on Nock need to be loose. A non-rail crossbow, the clip-on Nock need to be tight. You need to at least 2,000. That means you put a Nock on it, you cannot easily move the Nock left and right. The moment you did, that Nock is either worn or the string is no good. Now, the non-contained system. Why do I make this? Well, you can see that this reason because we got people who like Excaliburs or the Killer Instinct. They like the flat Nock because they thought you don't have to index the Nock. Yeah, but if you really know how to shoot, you need to index your shaft to start with. So if you index your shaft, what's the point of not indexing Nock? And this is one of the most dangerous. Because if you do not have down pressure on your string on your rail, this will have dry fire. That means you find out most of the quote-unquote flat Nock, the string is way below the rail on both sides because the string actually rubbed the entire rail in order to push this in perfectly. Is there anything wrong? No. That's the design. If that's not what they want to do, here it is. The case with the moon Nock. Yes, some people still like the moon Nock. It's very easy because you're not grabbing the string. But just like we all know, on a really misty day, when the deer is right under your tree, when you put your bow down and the arrow move forward because the knot is not grabbing the string, you have no shots. That's what you got. Now, why do I make this? This knot was made because of the days of Carbon Express and Parker. Yes, the Parker Red Hot is a Carbon Express private label arrow. So the ID is indeed 285. And if you shave the ridge again, you'll fit 270, which is your gold tip laser 2 kinetics. That pretty much concludes the entire Nock line. You can see there's 17 of them. But that is exceptions. You see the word plus? Why do I go that far with the plus? Because you know with the 300 ID there's a C knot and U knot. You notice that? This is for worn out Raven string, that's for brand new Raven strings. Okay? Those are great until you hit 500 feet per second with the axle around 5 inches. What's going to happen? Plastic as a material will no longer function. We now have to move to a whole different class of material, aluminum. You see, when I first make this out of 70-75, thinking of it's harder, now I got a problem. You start cutting servings. Not because of the sharpness of the Nock, it's the hardness of the material. Yes, aluminum have hardness. The harder you get, the sharper it gets, the more power you got, the easiest to cut the serving. So instead of using 70-71 T5, I moved to 60-61 T6, and all the problem goes away. Now, you notice that we actually using one of our older patent we own. This is a patent that we use in the target world. It's called square peg in the round hole. Yes, you hear me right. I'm putting a square peg in a round hole. Why do you want to do that? Because because the round hole you got is a carbon tubing. Carbon tubing have flax in it. Because you steel have no ability to give, but carbon does. So when you make a steel square tube with the round edges on it, you push in the carbon, you absolutely guarantee the knot will concentrate with the tube. And then yes, we have 2 sizes, the 125 and 135. And so the reason I make this is because, to be frank with you, the C plus is to fit 127 thousandths. We had to make it a little bit tighter. Because the original Raven R500, when it first come out in the market, is 127 thousandths. Unlike a plastic knot, there's no upward give. Metal don't give. The serving had to give. So now you see, if the serving is 123,000, then we have to make the knot 125 to capture it. See, these 2 ridges is what holds that in. In the case then, of course, we recognize that Raven had changed the string again. They added 5 thousandths to the new R500. That's the reason, instead of making this style, we make another one. And in order to distinguish the two, we added the U plus on this. So the C plus have no indication, the U plus will. Now when we run out of the old C plus, we'll put C plus on it too. So at this moment, if you don't see any indication, that's a C plus Nock. With indication, it's the U plus Nock. People say, well, you know, aluminum knocks are great. But everybody tried it and failed. They failed because they don't have this technology. They don't have a square peg in the round hole process. We own the patent to it. Because again, aluminum don't give, carbon 2 does. All right, now we talk about all the Nocks. Let's go into lighter Nock capabilities, the circuit boards. So you fully understand the basic components on the Firenock system. I do back and forward. Now we all know this coil. This wire is actually made of titanium. It's GL2 titanium and coated with 24 karat gold. It got 2 microns on 24 karat gold on it. The reason that I do that because this is the only way to guarantee anodization, oxidation did not form. Because if there's any oxidation process on it, there's no connection. Your Firenock is dead. Now, unlike any other lighter Nock battery in the world, you need to understand the Firenock pin 425 battery. The outside shell is positive. That means this is the positive end. The pin is negative. The original pin, the 425 or 435 battery, is actually designed by the chairman of Mr. Sushita way back then, which is part of Panasonic. He wanted a button battery that will go into fishing floats. So that you think about it, your baiting button shell on the outside is positive, the inside is negative. Now elongate the whole thing. That's what a 425 battery is. It's an elongated button shell. So the pin is negative and the body is positive. So now let me give you the basic anatomy of the entire Firenock circuit. Of course, the LED is in the front. The LED have two prongs, which soldered on the both sides of the circuit board. By the way, there's dual layer, two-side circuit board. This is the most important piece. That's a G switch. This G switch is one of the most expensive thing we in Firenock make. If you want to make that switch out of New York, the military contract, that G switch on the design would have cost you millions. Yes, I do mean millions. Let me show you the few things. See this line right here? That's boron laser weld. Inside here is hermetically sealed. The tip of this with the pin itself is made of stainless steel with a platinum tip and surrounded by glass. And the spring inside is a beryllium copper spring on a gold-plated ball. That's what this switch is. So as you shoot it, the ball, based on inertia, will push down to touch that at 65 G. That's how you activate Firenock. This switch is what the G-force switch is. By the way, this is not an inertia switch. It's a G switch. It's rated for 65 G. Why do I put 65 G? Because 65 G will let you do an arrow about 6 to 8 inches off the ground when you bounce the arrow off the ground. That itself is about 65 G. That's the reason behind this. Now inside this circuit, there's this IC. It's actually a VLSI. There's a 50,000, I'm going to talk about hunting circuit first, because the other circuits are different. The hunting circuit is a 50,000 transistor fuzzy logic computer. You say, what the hell are you talking about? Is it digital or is it analog? No, it's in between. Why is it so important to be in between? People say, well, you know, Firenock, you're so outdated, people use Bluetooth. Have you ever tried your Bluetooth headset without putting it in your ear? How good is it functional at 40 degrees or below? It don't work, isn't it? Do you know why? Because you're dealing with a battery. In order for all computer system to work and function correctly, it needs to have +3, -3, or +3 at least, and a 0. As temperature drops, the battery voltage will vary. In case of Firenock, on the 425 BR battery, it goes from 3.3 volt all the way down to 2.4. So where's your 3? You don't have a 3. The lower the temperature, the lower the battery voltage. The battery is still good, but lower the voltage. So can you maintain, just like your iPhone, you go hunting with it, put in your backpack, outside is about 14 degrees. When you go to your car, is your iPhone functioning? It's gone, isn't it? Your iPhone with a ginormous battery will not maintain logic. You think a Bluetooth in this situation will? You say, I use my Bluetooth in cold weather all the time. I understand. But you're putting in a ginormous heater. That's you. You're maintaining that in body or room temperature. The moment, what is maintaining your Bluetooth lighting Nock in that temperature or any digital circuit? Now, if you are old enough like me, you remember when Easton have the tracer. The moment it hit 40 degrees, every tracer will blink by itself. Do you know why? Because it can't maintain the logic. All the logic gates opens. So what did we do? Remember, this is original military product. This circuit board is a fuzzy logic system. That means it's not a square like digital system. It's actually behavior more like an analog system. It looks for which way it swings. It's on and off. This system will function from 55 below all the way to 180 degrees Fahrenheit. You say, wait a minute, no battery work that far. Well, you notice we have 4 batteries because those are temperature range. So it depends on what temperature you use is what battery you use. They have voltage difference, they have temperature variance difference, they have durability difference, and their shelf life difference. That's the reason we make 4 batteries. And right now, most probably in most cases, we show you the BR, which is our high power battery that we make once a year on July 4th. On June 6, 15, and will be in our hand by July 4th, every year. That is based on lithium manganese dioxide battery. That means it have a shelf life around 9 to 12 months. Can it go up to 18 months? Absolutely. Just like your battery. When they say died on 2023, does it mean that you have no power in 2023? No. It means that I cannot guarantee the reliability of that battery. Okay. Now you notice that is, you know, the basic formation of that. So this is how we name the Firenock system. The hunting, target, and I means intermittence, which means that we have the blinking circuit. The blinking circuit is very different compared to the hunting circuit and target circuit. The hunting circuit, believe it or not, is actually blinking 1,000 times on a 10,000 cycle. Yes, your Firenock hunting circuit is blinking 1,000 times per second. But it's on a 10,000 cycle. What does that mean? You're using 1/10 the power. Which also why a Firenock hunting circuit with a BR battery, you can strike it on October 1st. I got customer told me, by Christmas the sucker is still lit. And which I proved it using this computer system with our BR battery. If you put in -3 degrees, what happened is that the 10,000 cycle would drop to about 500 cycle. That means now the Firenock circuit at -3 degrees will blink 50 times per second. Now the Firenock will lit for just 367 days, which is just over a year. I think that's long enough.
Put it in our fridge.
Freezer. The target system, this is the only circuit lighter knock is legal in ASA and IBO. 2012, I talked to both of them. They have adjusted their rules and regulations. If you shoot a lighter knock in ASA, IBO sanctioned tournaments, if the lighter knock is lit when the next person shoots at the target, your point becomes 0. If your lighter knock is lit when you remove it from a target, your point is 0. So how do you use a lighter knock in those environments? This system is the only system have a digital cycle in it, a clock. That means the moment you shoot it, it'll stay on for 17 seconds and shut itself off. How reliable do you think this has to be? Imagine you just hit the 11 ring on the ASA target, and the Firenock circuit broke. You just lost 11 points. You must not play the tournament anymore. That's what the target first was. Hey, people say, I don't need a target, I hunt. I say, I understand, but hear me out. How many times you're on a tree and you got a chipmunk, squirrel, raccoon, a possum that just have to die? Do you want to shoot it with a lighter knock, like hunting or blinking? Answer is no. Because after you shot it, who's going down to shut it off? Do you just want to call it the day after you shot the possum, chipmunk, squirrel, or whatever? That's the beauty of the target knock. You shot it, you know exactly what it is, it shut off. Now let me tell you, for the truly hunting serious guys, say you got your hunt in Kansas, you're on a tree, a long doe, keep looking back, walk right in front of you. You got 2 tags. Do you want to shoot it with a lighter knock hunting or blinking? Hell no. You want to shoot it with a target. So you shot zip right through it. It's broad daylight. You know exactly where your arrow is. It's shut off. The doe walked far away, died. Now you got a live bait. And you do not have to go down to shut it. That's the beauty of the target knock. And then, yes, for people who practice, the hunting knock is great when you first look at a 50-yard target. Don't shoot the 50-yard target originally first time with a target knock. You will not find your arrow. Yes, shoot it with a hunting knock to know that you are at least within range before you start shooting lighter knock to shut up by itself. I got customer told me, I just shot it And then I say shake and run and run and run, and hopefully I will reach the arrow before the target knock shut off. Say, you are not Usain Bolt. You will not make it. It will shut off before you reach there. Now, the blinking knock. A lot of people don't understand the blinking knock. The blinking knock is a computer system that is totally different from others. Remember I told you this blink 1,000 times in 10,000 cycle? The blinking knock actually got a capacitor system in it. Yes, you hear me right. It's a capacitor system. Now imagine this. You're going to have 2 seconds. You're going to cut the 2 seconds into 10 sectors. You're going to charge the battery with 9/5 of a second, 1.8 seconds into the capacitor. Then you burst that 0.2 seconds with all this power. That reason is visible up to 1.2 miles in total darkness. That means if you shoot this lightning knock into alfalfa field, that's good. At night, the alfalfa field will give you a 2 meter to 3 meter halo. That means when you blink, you light up a light circle up to about 9 feet in the ground when the alfalfa is still green. And this is the lightning knock I suggest all my solo Western hunters. Buy 3 of them. Because when you get yourself in trouble, you need help, you call for help. You can put 3 of the circuitry on your arrow and mark it around you. This sucker will blink for about 2 to 3 weeks with a ring of fire up to 1.2 miles from the air. If they can't find you, what can I say? It's your time to go. There's nothing I can really do. If they can't find you with a 1.2 miles ring of fire, I don't know what to say. Okay, now you know these 2 circuits. And then I make them into N and K. Now this will work for all the Firenock knocks, all the crossbow, the regular bow. Then when we happen into the A knock and E knock, which your Access, your Michael Waddell, your Hex, your 235, that's what the narrow system is. And then what happens when we deal with the G knock? You can see that in the G knock, we make even thinner. And because we have no more room for the wire, we have stack coil. Now what does that mean? You put your battery into this. A lot of customers do not know that, and I will stress again. Remind your customer, you push the battery counterclockwise in, and you pull the battery counterclockwise out. A lot of customers come to you with a kink right here. What does that mean? They push the battery without turning the battery counterclockwise. They actually kinked the wire because they tried to push it in, and the wire grabbed the shell, and now they kinked the battery. After a while, they break right here. That's critical. The battery needs to be turned counterclockwise when you insert it. The battery needs to be turned counterclockwise when you remove it, because you try to unwind the coil as you push it in and push it out. But it's totally different in case of the G knock. The G knock, because of 166, in metrics is 4.05 millimeters. The battery is 4 millimeters. So you got 0.5 millimeter of space. This is 0.12 to 0.15 millimeters. There's not enough room to put around it. So what did we do? We put the battery with remember, every single Firenock comes with a tiny, tiny O-ring, like a sesame seed, which is an M1x1 O-ring. That is actually have 2 purposes. The first purpose is that when you install your end cap, the depth may not be perfect. The O-ring can be compressed to make sure it not fit perfectly. Second, in this case on the G knock, the O-ring is what prevented the outside wire touching the pin. That's the reason for the G knock is so critical. You put that O-ring in perfectly. And you do not twist this wire. Because the moment you twist clockwise, the wire will be twisted in and you will touch the connector. Guess what? You just killed it. You just shorted everything else. Hopefully you only kill the battery, but in some cases, you kill the computer board too. Is the end of the day? No. As a dealer, as for any customer, I give you a 30-day no-fault unconditional warranty on all Firenock products. As a dealer, they went through you. So if a customer insists they want to do it themselves, they go home, they screw every one of them up, they bring it back to you. You say within 30 days, give them a new one, I'll take care of the rest. But if they pass the 30 days, I think it's unreasonable, then they need to send it back for refresh. Now in the case of coils, you can see that that's when I talk about the double loop. See that wire? It's like a Berkeley snap that I designed. That was designed back in 2005 and I stopped using that in 2012. So that was out there for about 8 years. So some customers still have that. So don't be totally surprised when you see that. Because I know there's still customers using the 2006 Firenock for the last whatever years. Because the guys still call me once in a while, insist on one battery. Because see, I can't use 3, I just need 1. Well, what can I say? You got a customer like that. And then again, see, that's called a stack coil, that's called EC coil, that's called dual loop. Yes, I discontinued totally in 2014 because at that moment, every Firenock comes with end caps. As you can see that, now, this is important. As a dealer, I will sort of teach you. See this strip right here? Every single color LED, the light LED is clear. So how do you tell what color it is? On the wire side, I painted a color of the LED in it. If it doesn't have any color, it's red. That means if you see this one is white, that means a clear LED. If you see this strip is blue, there's a blue LED. That's how you tell. Because when you got a whole bunch of Firenock circuit in front of you, with every single one of them, that's for demonstration only, okay? Every Firenock LED that go on a circuit board is clear in physical form. When you put power through it, that's where you see the color. And which this strip right here is how you tell. Because see, when you get Firenock from me in the bag, the green and the red and the blue, how do you tell? Look at the wire side. Either side, you will see a strip of color. That's the color of the LED. If you see no color, it's red. All right, that will be the next one. Now let's take a closer look at the integrated circuit. I talk about the fuzzy logic, now we really dig into it. So you see how that works. We have a digital timer with a fuzzy logic computer and a motion sensor. So, wait a minute. It's a light and Nock. You have all this. You know why it is needed for all of them? Reliability. Because if I just use the G switch, what happens if you hit the tree and you exceed the 65G? If you don't have any of this, you just turn it on, you hit the tree, you just turn it off, isn't it? So how do you guarantee the light don't turn off? So the first thing I do, the moment you activate this, there's a 6-second time delay in it. There's a digital timer right on the get-go. That means the light cannot be turned on for 6 seconds. See that? It's a pure binary system. Is the light system on? Yes. Is the final origin? Yes. Then the G4 sensor? Yes. 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 Turn on the LED. That's how the LED is turned on. All of the above. Now, to turn it off, now that's a whole different ballgame. Because see, the moment, remember, after 6 seconds, if the deer got the arrow in, and the arrow is on the deer start running to the tree, and the deer hit the tree, you think that won't be 65G? So the light now will turn off, isn't it? So how do I prevent that further? This is what I do. First of all, in order to shut off Firenock, you need to hold the arrow motionless. What do you just did? You turn off the motion sensor. Why is the motion sensor important? Because the motion sensor is hooked up to the digital timer. So the moment you have no motion sensor, the digital timer starts counting. The moment you count to 6 seconds, the digital timer and the motion sensor both are off. So what's left? The G4 sensor. Now, which is always why you shut the Firenock. Hold it motionless, wait for a second, and drop. Because it's a tri-gate. It's a motion sensor with the digital timer and let the G4 sensor do the job. Because the G4 sensor is the only sensor that Firenock will be lighting up left and right, isn't it? Which means that how many times you know a deer will stand still for 6 seconds, turn his shoulder, hit the tree at 65 G to shut off the Firenock? Answer is that won't happen. That is the reason the Firenock is so reliable. This system was used in our hunting system with normal Firenock. Now for the intermediate system, the only difference is that you maintain the 6-second time delay. Then you charge the capacitors. Then every 2 seconds start blinking. But the same identical reverse processes. The motion sensor had to be off, the digital timer have to be off, then use G-force to shut the blinking. See, this is not that simple, isn't it? And for the target system, very easy. The moment you shoot it, the digital counter starts working. This is not a capacitor system. The Japanese pattern is a capacitor system. We are actually as a digital counter. We count 17 seconds, then we turn it off. Okay, well, let's go into chemistry. This is the batteries. You notice that we have 4 batteries. We dropped the BU, the BX is special order. That's made out of Pennsylvania. Okay? This battery will boil at 32 degrees. That means at ice temperature, you take this battery on your hand, you'll get burned. This battery should be operated always below freezing. It will come to you in a box in a dry ice. Because this battery will function at 55 below. You only got 3 months shelf life. That means you better be serious when you use this battery. It will cost you about $150 for that 3 battery. Because it comes with a box, a dry ice, and our FedEx to, say, Alaska, Ukraine, or whatever places you could hunt your polar bear or your mascot. Because none of the other will work. The BU is this one. We discontinue it because not many people buy it. The BU is a great battery. It's made by Panasonic's original. It's a lithium fluoride battery design. The beauty of this is that in normal condition, it will degrade 1% per year. Yes, you hear me right. It's a 200-year shelf life. I still have some battery I bought in 1974 when I was a teenager. It still works today, very dimly. But then the problem with this battery is that it's very consistent, but the brightness is technically nothing because it's a sealed lithium fluoride battery. Now we got a few chemistry out there, and of course this is all different. This one is the Korean made, based on the Panasonic, but it's open. This is what you have 3-year shelf life. But since it's based on open lithium fluoride battery chemistry, you can see the brightness. You can handle about in hours. See that the BR battery will give you a burn time of 1,000 hours. But the BR will give you 504 hours, the BU about 240 hours, the BX only give you 24 hours. But the brightness and the power is where the difference is. See the BL brightness? On the Luma side, it's about 25% less. But it gives you a 3-year shelf life. Very important, shelf life. It's not usage life. That means at the end of the season, if you do not take the battery out, by next season, all the batteries are dead. Because remember when I talk about the Firenock circuitry, it is a continuous monitoring system. The IC is constantly using power. It's like your computer, your car. Imagine this, you don't want to drive your car. You leave it there for 3 weeks, not driving it. You think the sucker will turn on? Just like you go vacation for 3 weeks, come back to the airport. Usually the first thing you do is call the airport security to help you to jumpstart your car. Because your clock, your whatever, drain the battery. Your security system, they all use. Just like the Firenock system, they use the battery if you do not remove it. So what's the thing you want to do? If you decide to use a BL battery, advise your customer, take the battery out and put it in the battery case if you want 3 seasons. If not, use the BL battery. You got the best of every world. It was made on June 15. It's good for about 8 months of time. Usually about 12. That's the reason when you look at my packaging, it will tell you it's good until next year. I give you 13 months to be safe. Theoretically, it's about 8 months, but I have not seen 8 months. For the past 12, 14 years, I see more like 15 months. But 15 months going to the second season, that means by October, that's no good already. which is useless. Now, very important, you see that there's tiny O-rings on it? Yes, we do sell separate O-rings. Because if you ever replace Firenock battery, that sucker would drop and you'll never into la la land. You'll never find it again. Isn't that the truth? Now, how do you install this? The easiest way is to hold this like a pin and put it on your palm and you push it down. So the O-ring will be under that. And now, a lot of times, a lot of customer dealers told me, there's already an O-ring there. No, that's not the O-ring. That's a dielectric separator from the pin to the shell. It's nothing more than a piece of hard plastic. You have no give. You always make sure you put the O-ring there. Now, there's another thing. For example, you accidentally install the Firenock too deep on the end cap. So now you hold the arrow and you can hold it like this. You can hear this shuffling. What do? Put on one more O-ring on it. You just pick up another millimeters. And in some cases, when you deal with matchway and so on, the customers say, oh my God, I put the Firenock together, I put a matchway in it, the arrow shake like crazy, you make rattling sound. What do? Go and get a Q-tip, pull some cotton off, throw it down in the arrow, push your Firenock, wake matchway in. You solve the problem. Because see, you can, unless you are superbly careful, your end cap is always going to be about 0.5 millimeter, 1 millimeter off. Because see, if I let you install the end cap too shallow, you will not be able to put the Firenock in. Am I right? So it's always deeper. But when it's too deep, you have two choices. Extra O-ring or throw cotton down it to prevent the rattling. See, small things like this. But that's the reason you take the class. Because see, those are the problem your customer tell you. I have the Firenock put together, when I shot it, it's rattling like crazy on the match weight. Oh, no big deal. Take it out, throw some cotton, put it back in, go shoot. All right, let's talk about the accessories. Extreme Shock end cap. Yes. So many of my dealers literally tell me, this is the worst thing ever happened. Then I told them, it's the best thing that ever happened. Because if you don't have this, there's no reliability. None. Because when you start shooting crossbow, and you're shooting a spiderweb target, if you expect whatever equipment you have able to hold the battery reliably, so we can pull the Firenock one and put in another one, you're out of your mind. Just like you prefer to drive a car because with just accelerator, you prefer no brakes. I know you can do that, but that's what they say, good luck. Now, you can see the Firenock system, see the number right here? XF and so on, see these numbers right here? That tell you which style of Firenock you use with what it is. Now, a lot of people say, Dodge, this AGO gel, it sucked. It only got 8-month shelf life and it's no good. I just installed some January. By June, this sucker is hard and I can't use it. I pay $11 for it. I say, okay, you can go to Walmart, paint section, get the Super Control Gel blue and silver bottle. What do? You're giving up 13,000 pounds per square inch to God knows what. Because every one of those, see, remember, there's only two, if not three, the third one is not confirmed in Europe, who makes super glue gel, super glue, raw material. Super glue raw material, unless you put stabilizer in it, you got about 12 months to deal with it. That means you make a big ginormous part and then you sell it to everybody within this time period. The moment, yes, you can put other stuff in it to make it last longer. Just like you make a big jug of fresh milk. What can you do to maintain it? Some people turn it into powder, some people take the skim milk and then they pasteurize it. But you know when it first come out, when you put a cup on it, it's a little bit oily, but if you drink it, it's nothing better. It's the best with all the nutrients. But if you turn the powder milk, well, you got 10, 20 years with it. But all the nutrients and good stuff's gone too. That's exactly why I go raw form. That's the reason every single super glue gel got a date on it. That date is important. People say, well, you know, sometimes before the date it got hard. It get really no good. Remember, conditions. What happened if I send you that thing, it was sitting outside your office or sitting inside UPS truck on the top shelf and the sun beat already 120 degrees, or in Mississippi with extreme moisture? Guess what? It starts curing. That's the reason. That is the time on it is for reference. Okay? That should be good, but sometimes it's not. If this is before that and it happens, well, guess what? I will send you a new one. There's nothing way I can do. I cannot control the environment. I cannot control how UPS or DHL or USPS ship it. It will happen. So when you squeeze out, you do look at the consistency, the viscosity. It should be about 10,000. That means you're able to squeeze it very comfortably, give you a bead of 1 millimeter. The moment you get hot to do it, that glue is no good. It's get too hot. It will not give you that 13,000 pounds per square inch. You say, I don't have 13,000 pounds. Excuse me, it's per square inch. When you glue a bit on your end caps, especially on the G-Nock, how many square inch do you think you got? You may get 1 millimeter square if best. So it's 25 times 25, 625. It's 1/625 of 13,000. It's nothing. So this number has to be really high because you are technically putting nothing there. Now then, what can you do to ensure your customer don't have problems? As a dealer, this is what you do. You install all the end caps using the super glue. Before you pull it out, you hold the end cap, you tuck. If it holds, great, unscrew it. If it tucks and it comes out, do not clean the shaft. Put more super glue in and push it down. Again, what you're really doing is you're building the glue in front of the end cap. What the whole idea of the gel compared to a glue, you are not gluing the O-ring. You're using the gel to form a dam to hold the O-ring with the cap. That's what you're using this glue for. That's the reason it's so thick. You're not gluing it. You're forming a dam in front of the O-ring. So, for example, sometimes when you push it down all the way to the bottom, you try to twist it. There's no glue on the O-ring. Where's the glue? Because the inside of the shaft is not perfect. So when you push it down that moment, any pits will eat the glue. So that's the reason when you pull it out, you can put glue again. Now this time is different. When you do it the second time, all the pits are filled up by the gel already. So in this time, when you push it down the second time, the glue is sitting in front of the O-ring. Now you got something solid. Can you do anything to improve it? Checking. Checking is the most important. So don't just put it in and just lightly touch it. No, you tug on it. Tug on the end cap too to make sure the O-ring is indeed binded with the inside wall of the shaft. Because remember, that battery on a crossbow who shoot 400 feet per second is exceeded 250. In case of the Raven 500, it exceeds 300 pounds. All right, now go to the match weight and other accessories. Those tools are the old accessories we still make. Those are the S-knot. That go into the fiberglass and the carbon-based bow fishing arrows. You can use the Firenock S-knot with it. See, you got an O-ring for the sealing. This whole thing is the Firenock match weight. You can see we make it for every single one of them. As a dealer, you buy that in bulk. Don't buy this pack. It's not worth it. Remember, this is $9.95 for a pack of 3 only. But as a match weight set, because you got extreme short end cap, it becomes $19.95 for 3. As a dealer, look at your price list. You got a really good deal on this. And you make a lot of money. All right? That pretty much is what the match weight is. Every single one have that. You can see that. We have match weight on every single style of Firenock. And that's our bow fishing system. Okay, finally, when you look at a Firenock system, you need to learn how the system works. Okay, the first character is the style of Firenock. The second number, like G3HR, when you buy a Firenock 3-pack, G3H-R tell you that it's a G-style 3-pack hunting in red. That's what it means. Those are not from fancy words. Just like some people went to Chinese restaurants and say, oh, what the hell is mugu gai pan? Mugu means mushroom, gai pan means chicken pieces. It's mushroom with chicken pieces. It's all it is. Same thing. G-style 3 piece hunting in red. So when you get a pack of Firenock, look at those, will tell you everything. If you are not sure, turn the package on the back. It will tell you in plain English, in long terms. G-style 3-circuit in hunting in red. That's what those words means. All right, that concluding our first sections. Any questions? Feel overwhelmed yet?